Good morning, everyone. Dear children, students, we are back to this class and we are dealing with ray optics. This is lecture number 3. We have not gone very far in the previous two lectures, and I hope that we can make for some lost ground in this particular one. I guess in the previous lecture we had talked about what is a plane mirror. I hope you remember what is a plane mirror. We had discussed what is a plane mirror. Plane mirror is something which has a one surface which is flat and the other side is painted, one side is polished, it is the reflecting side. We had seen that what type of object there, two types of objects are there and two types of images are there. Object is the point of intersection of incident rays. Remember, there will be always two rays in the discussion that we are doing. One would be incident ray and the other would be reflected ray in case of reflection, or transmitted or refracted ray in case of refraction. So image is defined in terms of reflected or the refracted ray, and the object is defined in terms of the incident ray. We had seen those definitions of object and image. We had also seen the difference between real image and virtual image. That was a quick wrap of what we had done in the previous class. I hope all of you remember this. Can I have some reason that we remember this, sir? Yes, I mean, I can't see the other class, but I hope that we remember this. Remember, I have already told you that before coming to a new class one night before, you must go through what we had done in the previous class. Having said that, we'll continue our discussion on plane mirrors. And now, since most of us know what is a plane mirror, we will write the important characteristics, and that is how you will write it. Important characteristics, important characteristics of image formed by a plane mirror. What are the important things that you must remember when you have a plane mirror and you have an image formed by a plane mirror? I hope most of you would know these points, but as I told you, I will be giving you everything point wise. Once I give you everything point wise, it becomes easier for you to remember. That is what I have always felt. So now let us make one plane mirror, and as you can see, this is my plane mirror. The hash 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 side is the reflected side or the polished side. Nothing happens on that side, everything happens in the front. So this is how I will draw it. Now I have put here a point O. Now this type of an object, which is simply a point, as you can see here, is known as a point object. We know this, yes or no? It's a point object. Now the object may not be a point. It can be like this. It can be a pen like this. It can be a sheet like this. We will deal with those case by case. Let us first start with a point object. A point object we have put, and the object is at point O. Now remember, there are terminologies that we are going to use in this chapter of refraction. The first term that is coming to us is known as U. Now what do you mean by U? I hope you know what is the meaning of U. You can also see it from the diagram. What is the meaning of U?
From mirror.
Distance of?
Object from mirror.
Distance of object from the mirror, that is known as U. Yes, that is correct. Now, it's a point object. It is going to create an image of this point object. Let me say that I hope you understand that image will be formed on the other side, and I call it as I. I is the image. O is the object. I is the image, and then we use this term for the image which is known as V. Now, can you tell me what do you mean by V?
Distance of image from mirror.
Distance of the image from the mirror. That takes me to the first point that we are going to discuss. Can you tell me what could be the relation between you and we? Distance of the object from the mirror and distance of the image from the mirror. What would be that relation? Anyone?
U is equal to V.
Yes, value of u will be equal to value of v. That means whatever distance the object is from the mirror, the image will be formed on the other side. On the other side. And the distance of the image on the other side will be same as distance of the object on this side. Remember, there are different ways of saying this. Sometimes we may call this side as the real side and this side as the virtual side. Do we remember this, beta? I told you different ways of saying the same thing. Real side, virtual side. So, object is on the real side, image will be formed on the virtual side. I hope we all understand this. I've written it in short, u is equal to v. You can write it in a bigger language. Distance of the object from the mirror on this side will be equal to distance of the image from the mirror on the other side. I hope everything is clear. Yes or no? We all know this, yes?
Yes, sir.
Yes. Remember, most of the things that we are going to discuss, you might have an idea about. You're just going to refresh it and write it point wise and remember them with diagrams and everything. If you can do that, well, I must congratulate you that you are doing good. Okay, can you tell me what would be the next point that I'm going to write? We have already discussed this. You already know it. There might be points that you don't know, but there are definitely points which you know. Yes. The object is a point object. U is equal to V. U is equal to V. That is the only thing we know, or do we know something else? No one has any idea? What would be the next point? The next point is right now on your screen. The next point is right now on your screen, which I have highlighted. We have already discussed this. What is the next point?
Point of intersection of reflected rays is known as image.
Point of intersection of reflected rays, image. We know this.
Real object will form virtual image.
Yeah, if the object is real, yellow, object is real, image is virtual. If the object is virtual, image is real. Do we understand this? If the object is real, I am writing it in short. If the object is real, image will be virtual. If the object is virtual, the image would be real. Are we getting this point, or is it going way above our understanding? Object real, image virtual. Object is on this side, image will be on the other side. Remember, we are talking about a plane mirror. If this would have been a different type of a mirror, the answer would have been slightly different. But here it is a plane mirror, and we are discussing image of a point object formed by a plane mirror. Do we understand this? I hope all of you are noting this down. Small points. Small points we are discussing, and we are going to write them. What could be the third point that I can write here? We are slowly moving towards the next point. What is the third point? If I can, oops, wrong color. What is the third point that I can write here? Now, this might be somewhat new to you. You might not understand this. So what I'll do is I will write it first, and then probably we'll try to make the sense. Line joining. Line joining object to image, I'm writing it in short, is always perpendicular to the mirror. A line which joins the object with the image. The line joining the object and the image will always be perpendicular to the mirror. Do we understand this? Yes or no? We're talking about a plane mirror. You can see in this diagram also. In this diagram also, the object is here. The image is here. And if I join the object with the image, which is the hash 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 line, this is the line that I'm talking about. This line will always be perpendicular to the mirror. Do you see this, beta? Small point, but it will make difference if you can understand this small point. Do we understand this, beta? When I have some reason that we understand this.
Yes, sir.
Now, I can make a question for that, and you will be able to answer it if you understand it. Let us say, for example, and I'm doing it in the same question. If I had the object here, no, this is just for you to understand. If I had the object here, where will the image be formed? Let me call this as O dash. If the object was here, not on the line that I've drawn, the object would have been here, where would have the image been formed? Now you can understand it if you know this third point that, sir, even if the object is here, where is the image going to be formed? In this case, object is here. I make a hash hash line, dug, 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 dug. Where will the image be formed? Can you tell me? Object is, I have put it below the original one. New object, O dash. Where is the image going to be formed? Yes, beta.
On the same line.
Yes, it will be on the same line because this line has to be perpendicular to the mirror. Everyone understands this, yes or no? Now remember, this thing is only applicable for a plane mirror. It cannot be, it is not applicable for curved mirrors, which we are going to discuss maybe in today's class, maybe in the next class. I hope all of you are making a sense of what we are doing here. Yes or no?
Yes, sir.
Okay. Now, there is one thing that you must understand, and which is not a characteristic. So I'll write it in a different thing, which is known as field of view. Have you heard this term, field of view? Anyone?
Yes, sir.
Field of view. Can you tell me what do you mean by a field of view, beta? I've just moved on. What do you mean by a field of view? So I'll just write it in a different color as an important point. Field of view. Yes, bacha. Field of view. What do you mean by field of view? Anyone? So tell me.
We will able to see the image in the field of view.
Yes. It is the region where you can see, region where we can see the image of the object. Remember this. We can see the image of the object. This is the region where we can see the image of the object. I hope everyone is understanding this. Yes or no? No or yes? This is the region where you can see the image of the object. Now, if I just show you this, if I show you this, Let me just put it here. I hope you can see this, bacha. This is the same diagram, but it's drawn correctly. So as you can see, here is the object, here is the image. Same thing is applicable. Object distance and image distance, both are same. Object is on this side, image is on that side, and all. Object is real, image is virtual. Now, can you tell me from the diagram, what is the field of view? I just drawn the correct diagram so that everything is geometrically correct. Remember, the name of this chapter is also geometrical optics, and that's a very important concept because everything can be found out by geometry. Simple geometry that you have studied in 6, 7, 8, 9, 10. Geometrical optics. Now, can you tell me where is the field of view? Remember, this is the object. This is the object. Let me make it yellow. This is the object, beta. This is the image. Now, I want to see this object. Oh, no. I want to see the image of this object. What is my field of view? Where can I place my eye where I can see the image of this object? Can you tell me from the diagram? That is why I've shown you the diagram, beta.
Upper ray to lower ray.
Yes, that's absolutely correct. Wherever this upper ray and this lower ray are going, right now in this diagram, they are actually going till infinity. So I should be able to see the object, see the image, so till infinity. So this is the field of view of this particular image. Do we understand this? Yes or no? Are we getting this, my dear friends? Can I have some raise hand that we understand this? This is what I call field of view, where you can actually see the image of the object. Well done. Have you drawn this diagram? You need to draw it if you want to understand the concept. I'll give you time to draw it. And since I've shown you a perfect diagram, your drawing may not be so perfect. You may not use scale and you may not use scale and all these geometrical instruments. You can just draw a simple diagram. Your lines may be going here and there. Doesn't matter. What matters is that you understand what I've drawn here. Since I wanted to draw it perfectly, that is why I have shown you this. I'll give you a minute till the time that you can draw this diagram to understand the meaning of FOW. I'll write it FOW, field of view, FOW. Remember the name of this chapter. Remember the name of this chapter is geometrical optics. Geometrical optics. Everything is about geometry. Plain, simple geometry. It's plain and is simple as well. Is plain and is simple as well. Once you are done, please let me know so that I can move ahead in life. We always have to move ahead in life. Can we move?
Done, sir.
Done, sir. Everyone in this class, which I can see. We are done with the diagram. We have drawn the field of view. Now comes the first question of this class that we are actually going to do. And are you ready for the question, everyone? Remember, this is geometrical optics, and this is the question that is there. Question number 1. Find the region on the y-axis in which reflected rays are present. Object is at 2, O. As you can see, object. I hope you can see this object. Object A. And the plane mirror is kept like this. It is a plane mirror and it is kept like this. Where is the field of view on the y-axis? Remember, y-axis. So what all points you can see the image on the y-axis. Remember, you'll have to remember simple things. You'll have to remember simple things. If I tell you simple things that we have studied, I hope you have seen the diagram. Can you get me the answer for this one? I'll give you 2 minutes to draw the question, and then we'll talk about the solution of how it's to be done. Remember, the name of this chapter is Geometrical Optics. If you understand geometry, and this is the best example that I can give you for understanding, to understand the geometry, you will be doing exceptionally well. Anyone who can get me the answer. Where on the y-axis is my field of view? Basically, it is just asking you to find out where are the reflected rays going to meet on the y-axis. Have you tried the question? Can I tell you how to do it? Since this is the first question, do you want me to solve it? Or you think that you should be able to do it on your behalf? Okay, I think that it would be good if I can help you out. Remember, in geometrical optics, and definitely in case of plane mirrors, may not be so much in the case of curved mirrors, but in case of plane mirrors, if you can draw the diagram correctly, you would be able to solve the question pretty easily. And this is the diagram that you had to draw. Now, let us discuss this diagram. This is A, this is the object. We understand this, yes or no? Then this green one is the image. We understand this, yes or no? And I've just told you, if the object is here, where is the image going to be formed? It has to be perpendicular to the mirror. My mirror is like this, tongue, 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 tongue. So the line joining the object and the mirror should be perpendicular. So that is the first thing that we have seen. Now, remember, the distance of the object and the distance of the image from the mirror has to be same. Now remember, how much is this distance? U. Can anyone tell me how much is U here? The horizontal distance, the distance on the x-axis. The object is placed at 2, 0. What is the image distance? What is the value of U? Yes or no? Do you know this?
2 √2.
Yes, but U is 2. Then you can tell me what will be the value of V. Then you can tell me what will be the value of V. V will also be 2. Yes or no? Yes or no?
Yes, sir.
Now, this is your origin, O, O. This is the point 4, 2. So how much will this point be equal to? This will be equal to 6, 0. Yes or no? Yes or no?
Yes, sir.
Now, if you can just see it on a bigger scene, this is my plane mirror. Let us say this is my y-axis. This is my x-axis. What I am doing here is drawing a bigger diagram of the same thing. Okay. Now my object is here, A 2, 0. My image is here, A dash 6, 0. Now I have to find out where is the field of view on the y-axis. So what I do is, whatever ray goes from here, reflected from here, it will go to this point. If this is N and this is M, this point becomes N dash. Are you getting my point? So this is the first point, the lower point where I am going to see the image. The image is here. When it just passes through this point, this is the point, the first point where I am going to see the image. Are you understanding this? Okay. If you understand this, then you can tell me how I can find the higher point. I told you how I found the lower point. I told you how I found the lower point. Can you tell me how can I find the higher point? How can I find the higher point? I found the lower point. I found the lower point by this ray. How I'm going to find the higher point? I am going to find the higher point using the green ray. Yes or no? So I draw the green ray. I start from this point. Tuck, 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 tuck. And then I see where is this striking the mirror, striking the y-axis. So this will be my M dash. And I just have to find out, I just need to find out how much is this distance. Let me call this distance as H. I just need to find out this H, and that will be my field of view. Are you getting my point? Yes or no? Is everyone getting my point? Yes or no? That is what I need to find out. Now, this question is a question of plane geometry. Now, this question is a question of plane geometry. Look at the yellow triangle. This is the yellow triangle. Do you see this yellow triangle? Right angle, yellow triangle. Yes or no? And then you just see this. This yellow, small yellow and big yellow triangle. The small yellow triangle and the big yellow triangle. They both are similar triangles. Small yellow and the big yellow, they both are similar triangles. You know this height is equal to 2. You know this length will be equal to 2 from here to here. You also know this distance is equal to 6. So you can tell me the value of this distance. What will be the value of this distance from similar triangle? Smaller is 2 and 2. Bigger one is 6. So the other one would be 6. Yes or no? Are you getting my point? So the bigger one will be 6. So the point of intersection, this N dash will be at 0, 6. On similar lines, you can look at the green triangle. This big green triangle. Big green triangle. Right? In this big green triangle, you can compare this big green triangle with the small green triangle, and the big green triangle. In the small green triangle, this is 2. What about this side? The highest point of the mirror. The highest point of the mirror. Look at the Y. Look at the X. The highest point of the mirror. Do we get this better?
1.
Yes. It is
1.
3 beta, na? 3. In the question it is given as 4, 3. Yes or no? So this is from here to where it is 3. Yes or no? This point is given as 4, 3. This point is given as 4, 2. Yes or no, beta? So the smaller green side is 3. So this is 3 and this is 2. Now you can tell me what about the bigger green side? Bigger green side. So 3 upon 2. This is 3. This is 3 and this is 2. So I can write 3 upon 2 from similar triangles will be equal to, let me call this entire thing as x. X, oops, why I'm using the same color. 3 upon 2 will be equal to x divided by this entire length is 6. So from here, I can get the value of x. The value of x would be coming as 9. So this point up till from here to here, it would be 9. This point, the lower point would be at 6. And how I have done this question? I have done this question purely by geometry. Are you getting me how I've taken similar triangles? How I have found out the field of view? It is very simple. Similar triangles I have used. I have taken one smaller triangle and one bigger triangle. I've taken for one point yellow triangle, yellow bigger, yellow smaller, similar triangles. Then I have taken green bigger and green smaller. And that is how I have calculated the field of view. If you have any doubts, you can ask me now. I'll give you 2 minutes. Try to do this question on your own so that you understand the concept. I'll give you 2 minutes to note it down. If you have any doubts, you can ask now. Is everyone okay? Have you understood what we were discussing, beta? Any doubt? See, a small doubt here can lead to bigger doubts in the coming days. So I would suggest you that if you have not understood, you can ask me if there is any problem.
Sir, one section. How would we get 0 n equals to 6?
How did we get
O comma n equals to 6. O n.
O A dash? See, beta, it's very simple. This distance is
O n dash, sir.
O N dash at 6. Similar triangle I have put, the yellow triangle. Yellow triangle. Look at the yellow triangle. This is, I don't know. This total length is 6. Do we understand this 6?
Sir.
This is 2 from here to here. Yes or no? Let me call this point as B. From B to A dash, it is 2. Yes or no? From B to N, it is also 2. So if I put it in smaller triangle, 2 by 2, 2 by 2, 2 by 2, 2 by 2, and let me call this as x dash. 2 by 2 will be equal to x dash divided by 6. Same thing that I have done here. Same thing I have done here. I have just used similar triangles. This is the green triangle that I have used. This is the yellow triangle that I have used. Am I clear? Yellow triangle, the smaller yellow triangle, both sides are 2 and 2. So the bigger yellow triangle, both sides are 6 and 6. In the smaller green triangle, the sides are 3 and 2. In the bigger greener triangle, it is 9 and 6. Same ratio because they are similar triangles. Am I clear, beta?
Yes, sir.
Okay. Have you drawn? Has everyone drawn this so I can move forward? Yes or no? Okay. I'll just give you a glimpse. Everyone has noted down. Okay. Now we had discussed 3 points for point objects. 3 points for point object. Now these 3 points we have discussed for point object. Now if I just change the question and instead of a point object, I make an extended object. Are these 3 points valid for an extended object? That is my question. So what do I mean by an extended object? By an extended object, the object would be like this. This is an extended object. The point we had written were definitely for point objects. Are they also true for extended objects?
Yes, sir.
Yes, they're also true for extended objects. Do we understand this? Yes or no? Everyone understand this? Small points, if you understand them correctly, then you will be able to make a lot of advancement in this particular chapter. So now I start with point number 4, and this point number 4, from this point number 4, these things are now valid for extended objects. So just for the sake of drawing, I'm again drawing the same diagram, but I am drawing it in terms of an extended object so that you can understand that right now we are basically talking about an extended object. OA is my object. O dash, A dash would be the image. Do we understand this, beta? Now, still the object distance is U and the image distance is V. So point number 1 is valid. That the distance of the object and the distance of the image from the mirror are same. I hope you understand this. U and V. Point number 2 was if the object is real, image is virtual, and vice versa. It is also valid. Now you can again see if I join the object with the image, any point of the object. Now there are many points here. If I join any point of the object with this image, and let us take for example this yellow line, the object O is here and the image is here, O dash, it is again perpendicular to the mirror. So all these points are valid. But now I have the height of the object. If the object is kept like this, I have height. If the object is kept like this, I have the length. Height, length, height, length. Now, no matter you keep the object like this or like this, let us talk about this object. This is an erect object. We call this object as erect object. This is an erect object. So now we can move on to the 4th point. The size of the object. Now, when I say size, this size can be the height if it's kept like this. It could be length if it is kept like this. What can you say about the size of the object and size of the image? Same, different?
Same.
Yes. Size of the object will be same as the size of the image. Well done. Now, I don't know whether I should tell you this, but have you heard about the term magnification? You might not have heard about the term magnification. Magnification is
Yes, sir.
size. Yes, beta?
Yes, sir.
You have heard about the term magnification? Well done. If you have heard about the term magnification, you can make point number 5. Magnification is denoted by the letter M. It is size of the image divided by the size of the object. So I standing for image and O standing for the object. Magnification is size of the image divided by the size of the object. In case of a plane mirror, what will be the magnification?
1.
1. So point number 4 and point number 5 are exactly same. Just saying it in different ways. In point number 4, I am saying size of the object is same as the size of the mirror, or they are equal. In point number 6, I am saying the same way. If I divide the size of the image by the size of the object, I will get 1. That is also known as magnification. So well done. We have understood one more term which we are supposed to do in curved mirrors, which probably will be starting in the next class. Magnification is image ka size or image ka height divided by object ka size or object ka height. That will be equal to 1. I hope everyone is there with me. Yes or no? Can I have some raise hand from everyone that we understand this, sir? Okay, so far so good, Abhiram. Well done. Let us now move and let us now concentrate on this green arrow and this blue arrow. Now we'll talk about these two arrows. Now I told you this green arrow, arrow is also green. There's a series on some channels which is green arrow. This green arrow, which is the object, is erect. What you can say about the blue arrow? Object is erect. What happens to the image?
Correct.
Image is also erect. Well done. That is what I mean to say. If the object is erect, the image is also erect. That is the next point that you will write. If the object is erect, the image will be erect as well. If the object is erect, image is going to be erect as well. I hope you understand this. Yes or no? No, yes. Can I have some raise hands from everyone? I hope I'm not making things complicated. I'm trying to simplify them and we are writing each and every point because beta, I know that any one of these points will be coming in your exam and I don't want you to lose out on any particular point. Now comes the 7th point, and to show you the 7th point, I will show you this. I hope you can see this. Now, the case that I drew was the object was erect, image was erect. Now, if I keep the object like this is the bottom point, and this is the top point. The object is kept like this. If this is the object, it is kept like this: bottom, top, bottom, top. Then you see how is the image formed. Do you understand how is the image formed? The image formed is like this: bottom, top, bottom, top. And you can easily understand this beta because the distance of this, if I call it u1, should be same as distance of this if I call it v1. So the point which is closer, the image will be closer. The point which is further, the image would be further. Do we understand this? Yes or no? Can I have some raise hand that we understand this? Object ka foot, feet is closer, therefore image ka feet will be closer. Object ka head is farther, so the image ka head would be farther. It is quite simple if you have understood this. Yes or no? No, yes. What I say, your raise hands gives me more confidence that I am on the right track. I hope you have noted this down, bacha, and we can move on to the next point. I'm happy that we have progressed quite nicely in today's class. I'm quite happy with this progress. So can I move on to the next point here, beta? Can I move on to the next point? Everyone is ready? Okay. Here comes the next point, and it could be only shown by the diagram, and that is why I have imported this diagram. We call it lateral inversion. Have you heard this term lateral inversion, beta? Anyone? Have you heard this term lateral inversion? If you write an R, and if you look at the image of that R, it will look inverted, right? If you point your palm like this, in the image it will look the reverse. Now I know you cannot draw this diagram because even I could not draw it, and that is why I had to say it, but this is just to make you understand that the image formed by a plane mirror is laterally inverted. And what I mean by lateral inversion, left is turned into right and vice versa. I know you cannot draw this R. I don't want you to draw this R. You can just simply, if I just draw it vaguely, how I will have done is I will write a R here and I will just write an ulta R here. That's it. That will make me understand that the image is inverted, laterally inverted, laterally inverted, laterally inverted. Right becomes left and left becomes right. I hope you are able to understand this. Again, raise hands gives me a lot of confidence that we understand this. Great, great, great. So I'm getting a lot of raise hand. That means we are on the right track. That is good. That is good. And let us move on to the next point. I hope you just have to draw the simple R that I've drawn. I just wanted to show you in real how it looks like. That is why I've just imported this. There is no complications regarding this. So that was point number 8. We move on to point number 9. And what do you mean by point number 9? It goes like this, and you must know that deviation caused by a plane mirror, and I hope you are writing it. Deviation caused by a plane mirror is 180 minus 2 times I. You say, what is this, sir? Whatever, anything you are saying, what is this? What do you mean by deviation, first of all? Now, if I could draw a simple diagram for deviation, let us see. This is my reflecting surface. It could be a plane mirror. This is my this is my normal. Every one of us understand this. This is my incident ray. The angle of incidence is I. Now, if I just trace this here, the incident ray actually goes like this if there was no surface. So this is the actual direction of the incident ray. Now, what happens is, since it encounters a reflecting surface, it will get reflected. The green one is always reflected for me. The blue one is incident, and the green one is reflected. So I'll use the same thing everywhere. So I is the angle of incidence, and this R is the angle of reflection, and I is equal to R. We already know this. Now, my question is, since I've written deviation caused is 180 minus 2I, what is deviation here? Deviation is an angle, obviously. Deviation is an angle. Which angle am I talking about? Now, this deviation will come in the concept of prism, how much is the deviation caused by a prism, and then you will see, sir, why this new term has come. This is not new. We have already discussed this. Can you tell me what is deviation?
Bending of light ray.
Bending of light ray? Not exactly correct. Deviation is an angle, beta. Deviation is an angle, beta. It's an angle. I'm talking about an angle. Deviation. Go for the English meaning of deviation. How much you have deviated from your path? You were going on a straight line, but now you have taken a turn. That means you have deviated from the path. That is angle of deviation or deviation of the ray. Now, can you tell me what is deviation? How much you have deviated from your path? That is deviation. Anyone? No one? Please give me the answer. I've told you the entire
Angle
thing.
between reflected ray and in the direction of I.
Yes, that is absolutely correct, beta. Look. This is the original direction of the incident ray. The incident ray would have gone like this. Zag, 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 zag. But Because of reflection, it has deviated. No, because of reflection, it has got reflected. Because of the surface, it has changed its path. It has changed its path. And its new path looks like this. The angle between the original path and the new path. The angle between the incident ray and in this case, the reflected ray is known as angle of deviation. This is delta. A Greek alphabet coming to our rescue. Thanks, Greek people, for giving us all these great alphabets. Greek alphabet delta. We are always going to use delta for deviation. Delta comes into the picture. This is the angle delta. Now you can easily understand from plane geometry. This is plane geometry. The name of this chapter is geometrical optics. You can understand that this entire angle is how much, beta? This entire pink angle. This entire pink angle is how much?
180, sir.
180, sir. Yes, sir. Then 180 minus, if you do I plus R, sir, you will get the angle of deviation, sir. But I is equal to R. So you can, instead of R, you can write I. So you can write it as 180 minus 2I. If you wish, you can also write it as 180 minus 2R. But normally angle of reflection is not given to you. It's only the angle of incidence that is given to you. And therefore, we always write it in terms of angle of incidence. So the deviation produced by a single mirror is 180 minus 2y. It is the angle between the original ray and the new ray, the reflected ray. Now remember, we're also going to see this angle of deviation in refraction. Again, it will be the same thing. What my original ray was, angle between that original ray, incident ray, and the ray which has come out after different things happening with it. Do we understand this? Can I have some raise hand? Your raise hand gives me a lot of confidence that we are going on the right track. Yes or no? No, yes. Okay. We are on the right track. And now I will write the last point for this particular class. And again, I will just show you the diagram, and what I need you to write will be just a single line from that diagram and nothing else. Because if I draw this diagram, it will consume a lot of time. So I'm just saving on some time and showing you that diagram straight away. And this is the diagram that I want to show you. That is point number 10, my dear friends. Now, what is this point number 10? To see the complete image in a plane mirror, if you want to see a complete image of yourself in a plane mirror, then the height or the length of this plane mirror, the minimum length should be half the height of the person. Now, this is just a derivation of this entire thing. What it actually means is this green is your legs, L. This pink is your head, H. And you want to see a complete view of yourself. You want to see how good or how bad you are looking in the mirror. Now, you'll always see, sir, I always see my entire self from head to legs in the mirror. Here we are talking about what is the minimum length of the mirror that you can keep that makes you visible completely from your leg, from your toe to your head. So what we are talking about here is the height of this object. The object here is yourself. If the height of this object is h, and you will just remember this as a fact. It will come as a fact. If the height is h, if your height is h, the minimum height of the mirror that you need is h by 2, and this is just a diagram illustrating the same thing. This E is your eyes, where your eyes are. So basically, this ray, the green ray, which is coming from legs, should reach your eye. As you can see, it is reaching your eye. And this pink ray which is coming from your head should also reach your eyes. If that happens, voila, you have seen yourself in the plane mirror, and the minimum height that you need is h/2. You may not draw the diagram, it's not relevant. Just remember this fact that the minimum length of the mirror that you want to see yourself completely is h/2, and these 2 points. This result does not depend on the position of eye. This is not dependent on the distance of the person. So you might feel, sir, if I go closer, I become smaller. If I go farther, I would be able to see myself in the mirror. No, dear. No, dear. Does not depend on the distance. That means if I call this as the distance, it does not depend on this distance. Whatever be your distance, does not depend on your distance. It does not depend on this blue thing. What is this blue thing? This blue thing is your height of the eye. If you're taller, you will feel, sir, if I'm taller, I would be able to see myself. Or you say, no, sir, if I'm shorter, my eyes are smaller, my eyes are at a lower distance, I would be able to see myself. No, no. Whatever your height is, whatever your distance from the mirror is, you can only see yourself from head to toe only if the length of the mirror is half of your height. Have you noted these 3 points? That is only 3 points that I have to note. Do we get this? Yes or no? Can I have some raised hands? This diagram I have just shown to you because I just wanted to see how it looks like. Doesn't matter. You just have to note down the 3 points and we are done. I hope everyone has seen this. Yes or no? So I hope you have noted this down. This brings us to the end of this particular session of thing. Plane mirror is still not done. We are still missing 2 or 3 points in that plane mirror, and those 2 or 3 points would come in your exam in JEE or NEET or JEE Advanced. So we'll wind up with plane mirrors in the next class with some wonderful problems as well. 2 or 3 problems, 4 problems, because there are not many problems here. So we'll be concentrating on the set of problems that we have. We will
Sir,
deal in the next class. Yes, beta.
sir, can you one show the page?
You want to see the screen, beta?
Yes, sir.
Just give me a second, beta. I'll just put it again. I thought that you have noted it down. But again, as I told you, you don't need to draw that diagram. The diagram is not relevant. I just wanted to show you the diagram. That is why I have shown you that. I hope you can see it now. Yes. Okay. You can note it down. I'll keep it on unless you finish this. But the diagram is not important because it would have taken a lot of time for me to draw the diagram. Time is a luxury that we don't have, and we don't need the diagram. We only need that point that we are supposed to know, because in the examination hall you are not going to draw this diagram. You just cannot draw this diagram. You don't have limited time. So you just remember these points, and I'm sure, and I'll show you questions coming from the same points in the examination hall. So I'll meet with you in the next class, Monday or Tuesday, and we'll try to wind up with more problems
sir.
on this. Well done, sir. I'll see you tomorrow.
Thank you, sir.
Take care and have a nice day. And if you have any problems anywhere, anytime, I'm always there to help you out. Okay. But remember, you have to promise me that when you come for the next class, you will go through what we have done in the previous class. Otherwise, the entire exercise would be a waste. And I hope you don't want to waste any time. Yes or no? Hello.
Bye, sir.
Take care. Have a nice.
Thank you, sir. Bye, sir.
Bye, beta.